Hello, trig fans, and welcome to another day. What a beautiful day outside. Sun is shining, sun's coming up. I hope everybody enjoyed St. Patty's Day and Double D opened up yesterday, national holiday. Hope you enjoyed that. I know Kirsten did. I know Natalie did because I saw their picture in the paper today. Hope you enjoyed your ice cream. Hope everybody was able to make it down there. Get a little bit of ice cream. If you didn't, maybe you can make it down there today. Today what we're going to do is we're going to continue on with the principal values and how we can come up with all these different values. On Monday and Tuesday we talked about we have an infinite number of values that we can have for a specific value. For that y equals 0.5, we have an infinite number of theta values that we can deal with. How do we come up with those infinite values? Because this only gives us one. How do we get the rest of them? So that's what we're going to be talking about today. After today's lesson, you'll be able to utilize your calculator to determine the principal values of trig functions, give two general solutions, and name the three smallest positive values. And that's what we'll be working on today. Hopefully you've been able to download the notes and print the notes off, and you can write on the notes as we go through this. Once again, if I'm going too fast, just hit your pause button and that will allow you to catch up. I won't keep talking when you hit the pause button. Alright? On the other day, on Monday and Tuesday, we talked about the principal value. The principal value is the calculator value. The value that you can pull off your calculator, that's your principal value. It only gives us one, but we're going to utilize that to be able to find and determine all the rest of the values. Now, how do we signify a principal value? When this letter is a capital letter, when this letter is a capital letter here, capital I, or a capital S for sine, a capital C for cosine, that means we're going to be dealing with the principal value, and that's all we're going to be working with is the principal value. Okay, so when this is a capital letter, we're going to just find the calculator value, which is the principal value. So go ahead and find the inverse cosine, or I'm sorry, the inverse sine of 0.73 on your calculator. And what you should get is 46.89 degrees. Which tells us if I would take the sine of 46.89 degrees, I'm going to approximately equal 0.73. Once again, when we have this inverse sine here, what we're talking about here is we're talking about the angle whose sine is 0.73. Okay, remember our translation we talked about the other day. The angle whose sine is 0.73. Now, how do I deal with this when it's a lowercase letter? Well, what we're going to be able to do is we're going to be able to find two general solutions and the first three positive values. So you may want to go back and pull your notes that we did yesterday and look at our notes yesterday, because what we will utilize is the cued questions I gave you in regards to what's the difference between angle number 1 and number 3, or number 3 or 2 and 4. Well, that was 360 degrees, which was the period. What was the relationship between 5 and 6? Okay, angle 5 and angle 6. I asked that question as I went down. Well, the relationship between angle 5 and angle 6 is they were supplementary angles. Okay. Now, when we dealt with the cosine on the back side, I asked you what's the relationship between angles 4 and 5, and they were opposite values. So those are the key ideas that we will utilize today to be able to determine these other values in these two general formulas. We will start out, we want to find two general solutions and the first three positive values. Well, we have the inverse sine of 0.73. So we should be able to find one value from that, and once again, that is called the principal value. And we found that up here is 0.4689. So theta can equal 46.89 degrees. This is the principal value. That's the principal value. Now, if we looked, I think this was number 5. Okay, this was value number 5 in our list yesterday when we were looking at the inverse sine of 0.5. Okay, if we looked at every other value, we can add 360 degrees, or we could subtract 360 degrees and be able to come up with another value. Where we had the value of 30, then we had a value here which was 150, then we had a value here that was 390 degrees, and when we went backwards, we had a value of negative 330 degrees. And if we would take the inverse sine once again, or if we would take the sine of negative 330 degrees, we get our value of 0.5. So what is happening here, this, if I did the inverse sine of 0.5, I came down to this value here, which was my principal value. To go and play leapfrog over other values. All we are doing is we are adding 360 degrees or subtracting 360 degrees. We had another value here, and then to get to my next value here, I can add my 360 degrees again, which would give us a value of 750 degrees. Once again, if I would take the sine to 750 degrees, I would get 0.5. So every other value that we have here, we can add 360 degrees, which is the period. So we can either add or subtract 360 degrees. Now, how we signify that we can get an infinite number of solutions here is we put a letter n in here, where n is a value of 1, 2, 3, 4, 5, and so on. It is a counting number. I guess we could probably put the whole number in here as 0, because it'd be redundant though. I'd just be able to get my same value. So I really don't need the 0 in there. I just need the values 1, 2, 3, 4, 5, and 6. Now how this works is I can pick any value that I want. I can pick any value I want for n. This pick our favorite letter or number 13. How this works is if I take theta is equal to 46.89 and add 360 times 13. And I could pick any number I wanted to. I just picked 13 because I like number 13. If we would find this angle value, so go and calculate it out, click it out, 46.89 plus 360 times 13. You should get an angle that is 44,726.89. Now what I want you to do is I want you to find the sine of that angle. So we take our sine of my answer, and voila, what do you get? 0.730043017. Because of rounding, we get to 0.73. If I would subtract, we'll make this one a little bit easier. 46.89 minus 360 times 10. Go ahead and find that value. negative 3,553.11. Now if we would take the sine of this angle, so let's take the sine of my answer, we get to say 0.7300430,117. It's like magic, isn't it? It's like I got my magic wand up here and saying, Ali Kababa, Shish Kumbah, poof, we get the same value. Well, the question is, what this gives us is this gives us, from the principal value, every other value. So I'm only getting half my values here. How do I get my second value? Well, what we need to have is we need to have two general solutions. Well, there comes the question that we had in our notes. If I scroll down to my notes from yesterday, if I would take the fifth measure and sixth measure, those two angles, add them together, they add up to 180 degrees, which they were called supplementary angles. So how do I get my second solution? Is we take a look at the idea of the supplement. Well, how do we find the supplement to 46.89? Well, that is the mathematical question we had to be able to deal with. Okay? If I have an angle, how do we find the supplement? Well, if I had the angle of 10 degrees, if my theta was 10 degrees, my supplement would be 170 degrees, because 180 minus 10 gives me 170. If my angle theta was 137 degrees, how would we find the supplement for 137 degrees? Well, we could sit there and try to figure it out in our brain, or we could take it a little bit easier and use our calculator and go 180 minus 137, and we should come down to 43 degrees. So if I take a look at 46.89 and I want to find the supplement, well, how can I find the supplement? I could take my 180 and subtract off the 46.89. So clickety-clack through the calculator. And you're exactly correct. It is 133.11 degrees. And what we could do, that gives us this value here. And then once again, to go every other from that, we can add the period, which is 360 degrees. So we can add or subtract 360 n. We'll just do one of these just to test it out to make sure. Oh, pick your favorite number, any number. All right, we'll go with the 17 then. So we have theta is equal to 133.11 plus 360 times 17. Go ahead and find that angle measure. Bam, you're exactly correct. 6,253.11 degrees. Now what I want you to do is I want you to find the sine of that angle. So I could go sine of my answer, and oh my gosh, would you look at that. My magic wand is out there again. We get the exact same 0.7300430,117. Wow, isn't that amazing? So these are my two general solutions. My next job to do here is find the first three positive. That means this is the smallest. The first three positives, that's the directions that you'll see in the book. That just means the smallest values. I want to find the first three smallest positive values that would work for this. So I'm going to get my blanks here. And if I take a look at my formulas, this tells me I take 46.89. I can either add or subtract 360 degrees. Well, if I subtract 360 degrees, I'm going to be negatives. So my smallest positive value here would be 46.89. Now remember, the leapfrog here, how I get every other one, I gotta switch formulas here. So I can come down to my second formula here. I can either add or subtract 360. Take this value, either add or subtract 360. Well, once again, if I subtract 360, hopefully we know that we'll be a negative number. So we don't want that value. So we're going to use the 133.11. At this point, we play leapfrog to go from 1 to 3. Just like up here, we add 360 degrees or we add the period. Now we're going to just have 360 degrees for right now, but eventually, as we work through these equations, the period will change. So I'm going to add the period, which is 360. So I have 46.89 plus 360 degrees. Which hopefully is 406.89. Once again, let's just check this just to make sure. Let's take the sine of 46.89. I'm sorry, 406.89. And oh my gosh, can you believe it again? Can you believe it? The 0.730043, it just continues to reappear. So the first two are the two general solutions and the first three positives here. That's the process we go to. That's for the sine. What happens when we go to the cosine? Well, when we go to the cosine, we're going to start out the same way up here. We're going to take the inverse cosine of 0.73 to find the principal value. So go ahead and take the inverse cosine of 0.73. And we get 43.11. Okay, and we're going to do the exact same thing here with the general formulas, because if we flip our notes from yesterday, okay, what we did yesterday when we were just dealing with the graphs, to go every other one, once again, we just had to add 360 or subtract 360 degrees. So we're still going to just add or subtract the 360n. Now the question I had for you as we went through the notes yesterday was, if we looked at value number 4 and value number 5, how could we describe value number 4 and value number 5? Well, how we describe them is one is a positive 60, one was a negative 60. Well, what do we call those? We call those opposites. So that's going to be true for our problem here. So this is once again the principal value, and down here will be our opposite. Well, what's the opposite to 43.11? That's a thinker. Negative 43.11, plus or minus 360n. And once again, I'm going too fast. When you hit the pause button, I won't keep talking. I will stop. Let's try that. Let's try this out this one out. Let's take negative 43.11 and let's add, let's see, 360, we'll go small this time, we'll go 7. Let's take the negative 43.11 plus 360 times 7. Find your angle measure. $2,476.89. Now what I want you to do is I want you to take the cosine of that value. So we go to cosine of the second answer, and oh my gosh, the magic wand came out again. It's still the same value, 0.730043011117. Just amazing, isn't it? It's like magic. The Pythagoreans just, they didn't know what they were developing. It was just pure magic. Okay, first three smallest positive values. Well, if I take a look at my first one, 43.11, if I add 360, I'm going to get bigger. So this is small. If I subtract 360, that's going to put me in the negatives. Don't want that. I want positives. 43.11. Now, I have a negative 43.11 here. That's negative. I don't want that value. I want the positive value. Well, to get the positive value, I can magically take negative 43.11 and add 360 to it, and that will give me my positive value. Once again, we're playing leapfrog here. We're playing leapfrog. Negative 43.11 would be here. I could play leapfrog by adding 360. So if we take negative 43.11, add 360, we get 316.89. And once again, to go from 1 to 3, we add the period, which is 360 degrees. So we get 403.11. And once again, if you want to just check that to make sure, take the cosine of 403.11. And magically, it will be the 0.7300 whatever. Now comes a little bit of a monkey wrench, not a huge one. We want to do the three general solutions. First three positives again, just like we did before. But now we're going to be dealing with the x variable. Theta, pretty easy. X, now we're going to do a little bit of it. It's not that bad. With the variable in x, what mode should your calculator be in? Okay, when we were in theta, we were in degrees. When we are in x, what do we need to be in? Anybody out there? Anybody out there? You're exactly correct. We need to be in radians. When you go through these problems, you need to check to make sure, what is my variable? Is my variable theta? So I'm in my degree mode. Or is my variable x? So I'm in my radian mode. So in my calculator, once again, just to review how to find the radian mode, I go to mode. My third one down here, I have radians and I have degrees. I'm in degrees now. I need to go down, get my blinker on radians, hit enter, it changes off degrees, and if I just want to check to make sure, now my radians are highlighted. So you need to make sure that you are in a radian mode. So now in a radian mode, we are not going to veer from what we did up here. Okay? We have cosine. When we had cosine, we had the principal value here, and then we have its opposite. So it's not going to change down here just because you change radians. It's going to be the same thing. So in my radian mode, I'm going to take the inverse cosine of 0.73. Let's again take it to 2 decimal places. And you should get 0.7524, so we will use 0.75. Plus or minus the period end. Well, when we are in a degree mode, we had 360. Now we have to think about when we're in radian mode, 360 degrees. What is 360 degrees in a radian mode? Correct. It's 2 pi. Because 360 degrees is equal to 2 pi radians. So we have plus or minus 2 pi, and then we're going to throw an n in there. You're going to take out the 360, replace it with 2 pi. And then our second value is the opposite. So x is going to equal the opposite of this, negative 0.75 plus or minus 2 pi n. Same idea, principal value, period, opposite, period. Now the first 3 positives. Now, this 2 pi, yes, it's 360 degrees in a degree mode. But in a radian mode, this is 2 times 3.14, which is 6.28. So that's a value of 6.28. So I either are going to add or subtract 6.28. Well, 0.7, if I subtract it, this is going to be negative. Don't want that, want the positives. So my first value is going to be the 0.75. This is negative, I want to make it positive. So I can either add or subtract this 6.28 and times any value of n. So if I take my negative 0.75 and add 6.28 to it, that's why I say go 2 decimal places so we can use 6.28. We get 5.53. And just like up above, to go from 1 to 3, we play leapfrog. To play leapfrog, we have to add the period. So we have 0.75 plus 6.28. .03. Now in a radian mode, it's just for giggles, let's take the cosine of 7.03. So in the calculator, take the cosine of 7.03. Once again, need to make sure you're in your radian mode. Now because of rounding, you're going to be not exactly 0.73, but you get 0.733856 and so on. And that's just because of the rounding that we're doing. Irrational number, we rounded 0.75 off, so you're going to not be exact with this. That's close enough for government work. The last problem we're going to do today is the inverse sine of a radian value. Well, when we were dealing with the inverse sine, our first value, once again, came from the principal value. So take, once again, make sure in your radian mode, inverse sine of 0.95. And you get 1.25 plus or minus 2 pi n. Once again, that's going to not change except for we're dealing with radians now, 2 pi n, not 360 because we're in a radian mode. Now, as we work the supplement up above, when theta was 121 degrees, the supplement we can find by taking 180 minus 121. So we get a value of 59 degrees. When my angle was, let's see, 162.3, the supplement can be found by taking 180 minus 162.3, which will give us 17.7. That's when I was in theta. How do we find the supplement in radians? Well, the question I ask you is, if I had 180 degrees in a radian mode, what is 180 degrees? You are correct. It's the value of pi. Because 180 degrees is equal to pi radians. So to find a supplement in a radian mode, to find the supplement, we have to take our 3.14 minus 1.25, because this is our value of pi. So we have 3.14 minus 1.25. 1.89 plus or minus 2 pi n. First three positives, once again, 2 pi is 6.28. So either add or subtract 6.28. Well, the nice thing about supplements, or I'm sorry, sines, you usually get 2 positive values there. They may not be the smallest one. You gotta watch yourself as we go forward. But we get 2 positive values. For right now, we have 1.25, we have 1.89, and then to go from 1 to 3, we play leapfrog. To play leapfrog, we add the period, which is 6.28. So we have 1.25 plus 6.28. So we get 7.53 if my math is correct. Once again, let's take the sine. 7.53. Once again, in a radian mode. And we get 0.9479754082, close to 0.95. Close enough for government work. So these are our first three smallest positive values. So what to pull from this? What to pull from this? If we are in theta and degrees, we have x, we are radians. Okay? Our two general solutions when we're dealing with sine. We have the principal value plus or minus the period n. And for our purposes right now, this is 360 degrees. We have the supplement plus or minus the period n. If we're dealing with, I'm sorry, this is an inverse sine. Inverse cosine, we have our principal value plus or minus the period n, and then we have the opposite plus or minus the period n. And once again, the period for our cases will be 360 degrees for right now. We're in radian mode. These are still the same thing. This all goes over here. We just need to make sure the calculator is in a radian idea. And the period over here, for these cases right now, will be 2 pi. So we have principal value plus or minus the period n, and then we have supplement plus or minus the period n. But once again, the supplement, how we find the supplement? This is 3.14 minus the principal value. That will be the supplement. And then the cosine is the same thing. You do have some book work today. On page number 81, 3 to 39 multiples of 3. Page 81, 3 to 39 multiples of 3. Tomorrow, I'll just come in, we'll have a video. I'll go through some of the problems that you had for homework for today. And I won't push too hard through this. But I'll give you some problems and maybe give you some additional problems to be able to work to get you some extra practice with this basic idea. Where this will lead into is we'll get more complicated equations. We'll be dealing with a little bit more complicated equations as we go into Friday at that point. Once again, feel free to view the video, feel free to stop at any point. If you have questions, feel free to email me. I check them throughout the day to see if you have any questions. I know we've had some technical difficulties in some of the other classes in regards to the videos every once in a while not operating well. So just bear with us as we mud ourselves through the problems here and through VLA, Downton Style, Virtual Learning Academy. Okay. Hopefully you're keeping up with the material. Hopefully you're staying safe, keeping your social distances that you need to. Make sure you get your double D ice cream. They should start paying me money for all the commercials I give them. Tomorrow's the first day of spring. There we go. Got a sunny day today. It's supposed to be warm, 70s or 60s. Gonna be nice. Stay safe. Stay out of trouble. Get your work, make an attempt to get the work done here as you can. You have nothing else to do. Might as well just sit around and do some math work, your most favorite subject. Once again, if you have any questions, feel free to email any of your questions. If you have questions about particular problems, I will go over them the next day. I'll post a video going over the problems. Stay safe. enjoy your day. Adios, amigos. I miss you guys. You know what? I enjoy you guys. I miss you guys. So, you have a good day.